Hi guys, welcome back to channel Ask Said How To. So today we'll see how to read your Sanger sequencing results using the Chroma software. There are many softwares like Finch TV and others, but today we will see how to use this one. So as you can see on my screen, I've already opened the user interface. So I'll not bore you with what all the definitions are. I'll just take you directly to the main things, right? So here is the definition, I guess. In the software you can easily find it, so you can read it very easily. It says if a colored bar appears above each base, it represents the order of magnitude of the probability. So when we'll start reading the data, we'll get to know how and what to read. So basically, if the bar is full, the color is full, we'll see what bar we are talking about. We'll get to know uh, you know the quality of results. So if the bar is full, it says the probability of its incorrectness is 1 to the 1 is to 10 to the 1 is to 10 lakh, right? So it's quite good, right? So we'll start with the data analysis. So I already have some of the downloaded data. I'll just open some of them. So I'll open this one and we'll try to analyze. So this is a data file, basically Sanger sequencing data, and how to use this software. Basically this video is all about that. So we will see what all we can use here. So this is, as you can see here, reverse, to just make it reverse complement. So if you click here, A will become D and so on. The colors you see here are different colors denoted by the software as only, so it is easier for us to find out. For example, green is used for A, red is used for T and so on. Now that full bar color I was talking about, here you can see this C is having full color, right? And here this A is having less than half. So right, so this means that the software or the results that you have got are more confident that whatever the results are shown here, if this area is red C, that means it is much sure about it. And that's all. So we have this zooming bar here. So if I use it, it becomes something like this, right? And to move it left and right, I will use my keypad. So this way I can move it. So as you can see, it is a very nice and clear chromatogram with very less noise. Okay, somewhere you can see like this, uh, you know one peak over the other. So this area is generally denoted as heterozygous condition, right? Same way, if you move till the end, what we'll see, it's quite big. As you can see this bar, I'll take it directly. Yeah, so it can read till 430, right? So the the size of the read is 430, but you will see after that also there are some lines are there, colorful lines. So basically this is the noise, the dye is there, whatever is added to the sequencer. So because of that the machine reads some of the signals and you can see this. So you just need to ignore this. Okay, and in the starting also you can see there is some noise. So I think around first 20 to 30 basis. So this becomes this comes due to this uh, dimer and all. So we need to be checking it after 20 base pairs. Okay, 20 to 30. So next one is I think find is there. So you can just type any of your sequence. For example, if I type GCC or anything you want to search particularly, you just type it here and click find next. So if it is there in your sequence, it will find. So you can see here GCCC like that. So this is the use of this find option. Then next what we have here is you can also export it uh, and you can do the batch processing. For example, if I want to use directly, I mean at once I want to use or compare two different sequences, I can open at once also. I think there is no limit for that. I have used 4, but I don't know what is the max limit. Will let me know in the comments. The next is the blast search, right? These are some of my last opened uh, data sets. So if I do the blast search, I click here, and all these I will not be changing. Blast versus nucleotide, everything will be same. Region I can select from 1 to 430, will automatically read. But if I want to change, for example, I just want till 400, I'll type 400. Okay, and expect 10 means this is the highest quality ratio. uh, if you go here, it will be very much precise, so it won't give you proper results. So let it be like that only, and click send. So it will open in CBI blast. We'll see the results. As you can see here, it has shown me some again one new window. Now what I do here is just I click here for view report. Okay, so it will show me the uh, query alignment scores, and here you must be knowing how to read all this, because if I start teaching this, it will be a very long video. So all that I will cover some other day. But if I just click at any of the uh, red line, I'll find out what my from which gene or SNP, whatever it is related to. So if I just click here again and I check for the alignment, it will show me accession number and all. It will bring me here, right? So if I see here, it is showing me query, that is what data I have given, and the subject, that is the actually what is present in the database. So with this I can match it and check for my results, right? And this table will show me where my maximum that sequence aligns with. So it shows query result 96%, so it is quite good result. So this way I can check where all my sequence of interest is found, in which all animals or maybe plants also, gene depends, right? So same way now we'll see, this was a quite good, what do you say, data set. So now we'll see how does a bad sequence looks like, because we need to know both. So we'll just go to file. I have a bad one also, right? So just click here, open, and this is a quite disastrous one, right? So here you can see it is almost completely empty. Here you can see one peak, but this is not a peak, this is what experts call it as a bubble. And here you can see it is having a you know a blunt line, and if you try to zoom it here, all these, there are small peaks, but it is not being read properly because of impurity or other issues. So that is the, maybe the you know uh, machine didn't work properly due to various reasons, right? So if we drag it to the right hand side, you will see what type of chromatogram we have got. So you can see a lot of noise. Noise means nothing but a mixture of what do you call this, peaks, right? It is not very clear. Basically everything is overlapped. So of course there is nothing more than heterozygous. We have homozygous and heterozygous. I don't know what is quadrozygous, right? If you know, let me know if you discover something. So this is the sequence, and it is quite disturbing. So this will be generally rejected, and this won't be considered as a good Sanger sequencing result, right? So I think it has already ended here. Yeah. So after this, what all it has read is just the dye that is giving its traces, right? So this way we can check, and if you want me to open two files at a time, we'll try batch processing. Okay, maybe this one is already open. This one I'll open. Okay, already exported. So you can check it and trial. This is a free software, so you can download it right now and start working on that, right? Or what you can do is you can always do this as well, right? So this is the better version of the results.